Drive down any major modern highway, look up at the towering, brutalist overpasses stretching across the skyline, or simply glance down at the ordinary, cracked sidewalk directly beneath your feet. You will immediately see a world entirely built on a single, ubiquitous, heavy foundation. Concrete. It is the undisputed, heavy gray bedrock of our modern civilization, the essential canvas upon which our entire industrialized, fast-paced society is painted. We trust it implicitly, almost blindly, to hold up our massive skyscrapers, to solidly bridge our widest, most turbulent rivers, and to pave our endless, sprawling continents. We pour billions of tons of it into the earth every single year, reshaping the very topography of the planet to suit our modern needs. Yet, despite its overwhelming global presence, and despite the untold billions of dollars poured into refining its modern chemical formulation in advanced laboratories, we have collectively accepted a devastating, deeply undeniable truth about this miraculous building material. It is inherently, fundamentally flawed. Cracks. It crumbles. Beneath its illusion of permanence, it is deeply, structurally fragile. We lay down a pristine, multi-million-dollar stretch of modern highway, and within a single brief decade, it is riddled with jagged fissures, severely pitted by winter salt, and heavily bleeding the rusted orange streaks of decaying internal iron rebar. We simply accept that our massive public bridges will inevitably require dangerous, incredibly expensive structural overhauls and constant patchwork within our own lifetimes. We believe, without question, that concrete, by its very chemical nature, is a temporary, disposable material, entirely doomed to fracture and fail under the relentless, everyday pressures of fluctuating temperature, invasive moisture, and passing time. We spend astronomical sums of money patching, replacing, and desperately tearing down what we confidently built just one generation ago, forever trapped on an exhausting treadmill of structural decay. But what if this constant, frustrating cycle of chemical failure and structural decay is entirely unnecessary? What if the underlying assumption that concrete must inevitably crumble into dust is a uniquely modern failing? To uncover the genuine truth, we must leave the crumbling, rust-stained infrastructure of the 21st century and travel across the globe, reaching deep into the heart of the ancient Mediterranean. We must look closely at the sweeping, impossible arches of the Roman Empire. 2,000 years ago, ancient engineers were confidently constructing monumental megastructures of unparalleled ambition and breathtaking scale. They built massive, unsupported domes that rival anything mathematically modeled today. They engineered towering, multi-tiered aqueducts that gracefully spanned deep, treacherous valleys, carrying thousands of gallons of fresh water for miles. They built colossal, heavy seawalls that plunged directly into the violent, churning saltwater of the Mediterranean coast. They did not have steel rebar to reinforce their structures. They did not have computer-aided stress models to calculate wind load. They did not have modern Portland cement manufactured in high-heat industrial kilns. And yet, while our modern, heavily reinforced highway bridges are routinely condemned and demolished after just 50 years, the structural marvels of the ancient Roman world are still standing, defiant and completely intact. The Pantheon in Rome, crowned by the largest unreinforced concrete dome in the entire world, remains perfectly structurally sound after nearly 2 millennia, entirely open to the elements. The massive, heavy concrete piers submerged in the harbor of ancient Caesarea have been violently battered by relentless ocean waves for 2,000 years, and rather than eroding away into the sea, they have actually, miraculously grown stronger. How is this physically possible? How did an ancient civilization, lacking entirely in modern synthetic chemistry and heavy industry, engineer a building material that entirely defies the fundamental laws of structural decay? The answer lies in the deeply misunderstood, almost entirely forgotten recipe known historically as Opus Caementicium. For centuries, modern historians and structural engineers simply assumed that the Romans just happened to get exceptionally lucky with the dirt they blindly dug out of the ground. They analyzed the ancient stone in modern laboratories and found that it was primarily a mixture of volcanic ash, known as pozzolana, combined with chunks of volcanic rock and lime. Modern architects scoffed at the seemingly primitive mixture, quickly noting that Roman concrete was significantly weaker in basic compressive strength than the highly refined, heavily regulated Portland cement we churn out of modern factories today. But the modern world was completely measuring the wrong metric. The breathtaking genius of the ancient Roman builders wasn't in engineering a material that was perfectly rigid and mathematically strong. It was in engineering a material that was actively, chemically alive. To understand the profound, forgotten science of ancient concrete, we have to deeply examine the exact physical process of how it was mixed, and more importantly, what chemically happens when it inevitably breaks. When modern concrete cracks, and it always, without fail, cracks, water inevitably seeps deep into the new fissure. This trapped moisture rapidly corrodes the internal steel rebar, causing the metal to aggressively expand and violently blow the concrete apart from the inside out in a process known as spalling. Water is the ultimate destructive enemy of the modern engineered structure. But to the ancient Roman engineer, water was not an enemy to be feared and sealed out with synthetic plastics. It was an active, highly necessary ingredient. The profound secret lies in a specific, crucial flaw in their mixing process, a physical anomaly that modern chemists actually spent centuries trying to correct. When you look closely at a cross-section of ancient Roman concrete under a microscope, you will immediately notice something the modern building codes would instantly flag as a catastrophic, dangerous failure. The ancient stone is heavily peppered with tiny, bright white, seemingly unmixed lumps of raw material. These are known as lime clasts. For generations, modern engineers confidently dismissed these white chunks as evidence of sloppy, primitive mixing techniques. They assumed the ancient laborers simply weren't stirring the batter hard enough or were rushing the job. They couldn't have been more wrong. These lime clasts were not a mistake. They were a brilliantly calculated feature, introduced through a highly specific, dangerous, and volatile process known as hot mixing. The Romans did not simply use slaked, pre-mixed lime like a modern mason laying brick. They took completely dry, highly reactive quicklime raw limestone that had been superheated in a kiln to drive off carbon dioxide and mixed it directly with the volcanic ash and water all at once. This sudden combination triggered a violent, extreme exothermic reaction. The mixture literally boiled in the hands of the workers. This intense, internal heat fundamentally altered the chemical structure of the material, curing it rapidly while simultaneously trapping those tiny, unreacted lime clasts deep within the final, hardened matrix of the stone. Why would they intentionally trap unmixed, highly reactive quicklime inside the finished concrete? Because they were brilliant enough to build a dormant, chemical immune system directly into the walls of their cities. Imagine a heavy, ancient Roman aqueduct shifting slightly during a minor, passing earthquake. A microscopic, invisible crack forms deep within the massive stone structure. In a modern 20th century building, this single crack is the inevitable beginning of the end. But in the Roman structure, a miraculous, entirely passive sequence of chemical events is immediately triggered. As the next seasonal rainstorm hits, water naturally finds its way into the tiny, newly formed crack. As that water travels deeper into the dark fissure, it immediately encounters one of those intentionally trapped, unreacted lime clasts. The dormant, waiting quicklime instantly reacts with the incoming water, creating a highly saturated, calcium-rich alkaline solution. This dissolved calcium washes directly into the empty void of the crack. And then, as the water begins to naturally evaporate into the air, the calcium rapidly crystallizes, forming solid calcium carbonate. The crack literally scabs over. It physically knits itself back together, bridging the gap with fresh, solid stone, completely sealing the open wound long, before the fracture has any opportunity to spread and compromise the structure. It is an autonomous, self-repairing material that requires no human maintenance, no external chemical epoxies, and no modern interventions. This astonishing self-healing mechanism becomes even more spectacular when the concrete is completely submerged in the ocean. The Roman engineers intentionally sourced specific, highly reactive volcanic ash from the volcanic fields of Campi Flegrei near the Bay of Naples when building their massive marine piers. When the aggressive, highly corrosive saltwater of the Mediterranean inevitably seeped into the ancient, submerged piers, it didn't erode the structure. Instead, the saltwater reacted violently with the unique volcanic ash and the trapped lime, triggering the continuous growth of a rare, exceptionally strong interlocking mineral called aluminum tobermorite. The very saltwater that completely destroys modern marine infrastructure within decades was essentially used by the ancient Romans as a continuous strengthening agent. The longer the structure sat in the churning, violent ocean, the harder, denser, and more impenetrable the stone actively became. It is not a mechanical approach to engineering, it is a deeply biological one. So, if this ancient, forgotten recipe is so vastly, undeniably superior if it naturally heals its own cracks, actively grows stronger in corrosive saltwater, completely avoids the use of rusting internal steel, and lasts for thousands of years, why did it disappear from the modern world? Why are we currently surrounded by a decaying infrastructure that demands endless, toxic maintenance? The tragic loss of this immense wisdom is deeply tied to the sudden, violent collapse of the Western Roman Empire. As the highly organized, centralized state completely fractured into chaotic, isolated territories, the vast, intricate networks of maritime trade that transported the specific, necessary volcanic ash across the Mediterranean completely broke down. The highly specialized, heavily guarded generational knowledge of hot mixing was lost to the violent chaos of the Dark Ages. By the time humanity slowly began to rebuild massive concrete structures during the height of the Industrial Revolution, we had completely forgotten the deep chemical elegance of the ancient world. In the early 19th century, we invented modern Portland cement. It was a massive, celebrated industrial triumph, perfectly, flawlessly suited for the incredibly fast-paced, highly profitable demands of modern capitalism. Portland cement cures incredibly quickly. It possesses a very high initial compressive strength. It elegantly allows modern construction contractors to pour massive, towering foundations in mere days rather than months. But this modern, global obsession with absolute speed and maximum profit came with a terrible, hidden long-term cost. We aggressively traded the active, self-healing permanence of the ancient world for a rigid, incredibly brittle material that actively fights its environment. We stopped partnering with the natural elements and started desperately, hopelessly trying to dominate them. We designed our cities to exist in total opposition to nature, and nature is slowly, inevitably tearing them down. We do not all need to immediately abandon modern engineering, dismantle our cities, and begin superheating raw limestone in our backyards to build ancient, self-healing aqueducts. The modern, globalized world relies heavily on the rapid, standardized, predictable nature of industrial cement to house a massive population. But the deeply forgotten, breathtaking wisdom of Roman concrete holds a profound, urgently needed lesson for our modern society. It serves to remind us that our default, modern approach to problem solving is almost always to aggressively prioritize raw, unyielding strength and immediate, frictionless speed over long-term, working resilience. We build things completely rigid, heavily expecting them to perfectly resist the immense, chaotic forces of nature, and we are constantly, foolishly surprised when they inevitably break under the pressure. The ancient builders understood a deeply humbling truth that we have entirely forgotten in our rush to modernize the globe. They knew that you cannot ultimately defeat the elements with sheer, unyielding force. Everything eventually cracks. The true, hidden secret to permanence is not in trying to build something that never breaks, but in beautifully engineering something that knows exactly how to heal. If this kind of forgotten practical knowledge matters to you, subscribe to Forbidden Vaults. Because the next vault opens another method, modern life almost made us forget.